model validation. So the section 1 is model definition and the identification. And first of all, we need to define what is a model. So model basically, the first of all, it should have some assumptions and also have it's complex, not only some kind of formula in Excel, and that usually we call it a calculation tool. So that's the definition that from the supervisory guidance, and that is the definition we basically follow. And you can look at the details. Since I have more than 40 slides to go through today, so I'm not going to get into a lot of details. So this slide, I'm sorry, that slide was talking about the different type of model in banking, and that's basically we have business decision making models, and risk management models, and financial reporting models. And so in practice, and we have model definitions varies in scope and the theoretical application to activities conducted within the banks. So from this slide, you can see from low to high level of this expensiveness, and we have a different definition on the model. So it's also the observation from the industry is different. So the model used by banks internally developed, but some models actually you can purchase from a vendor. So for those models, the internal developed models and vendor models, they really have some pros and cons for each one. So for example, in the internal developed models, the banks can control all the aspects of the model development, and they can ensure the resulting models is tailored to its particular needs. And also typically using the internal data, which is more preferred by the regulator, and the model development team will know all the details of how the model was developed and tested. So for vendor models, and because the efforts required to develop and maintain a model is performed by the third party, so it saves a lot of time for the bank. And then the vendors have contents expertise in the area they develop in selling the models. So they also able to customize some models to fit in the needs for a certain bank. So the major vendors like like Moody's, S&P, Intex, and those big model designers, they usually sell certain models to big banks. And there are also some disadvantage for internal models that maybe you're challenging when the internal data is limited, and sometimes you don't have the data, long enough data to be modeled on. But for vendor models, and the ongoing cost to purchase and maintain the model is very high. And sometimes like vendor models, black box model, and when you do your internal validation, it's very difficult. Those costs, they don't offer you detailed methodology in the code that they have, because they want to sell it, so they really won't give you the details on the model. So modifications can be expensive. And for practical use, the internal model, internally developed model, typically used whenever possible. So that when the bank are trying to save money, and they usually most of the models, they usually internally developed. For the vendors model, the most useful for complex modeling. Complex models, for example, the risk watch, probably most of the people heard of it. And vendors model are still subject to model explain the risk management governance. Even its vendors model, when the Fed or OCC come to a bank to examine the model, to do the risk review, and you can't say that's the vendor model, we're not responsible. So we still have to do the model validation. So we're going to talk about the details of model development process. I think that's basically everybody interested how the can be used in banking, basically used for develop a model. So we're going to basically talk about from three perspectives. There's regulatory guidance around model development, an example of leading peer practice, and the typical steps in a model development process. So we have this regulators have provided some guidance around the expectations of a leading model development process. And the area can include the developer's qualification, about the staff, and are they appropriately trained? Do they have knowledge, expertise, judgment, and do they have enough knowledge about the business? All those stuff. And then model scope, it's a clear statement of a purpose of ensure that development is aligned with the intended use, and the interaction with other models is clearly identified and documented. So model theory, it should be supported by the published research and sound industry practice, and methodologies and processing components are explained in detail with particular attention to merits and limitations. And components works as intended are conceptually sound and mathematically correct. And those theory has to have comparison with the alternative theories and approach provided. Usually, we have challenger models, so you can compare the output and the results. For the modeling data, and should rigorous assessment of data quality and relevance and appropriate documentation. The data should be consistent with the chosen methodology, and data proxies are carefully identified, adjusted, and documented. Any justification are transparent and should be well documented. Also, those testings, the model testing accuracy is model accuracy is being tested, and potential limitation are assessed over a range of inputs. Models performance under a variety of market condition is thoroughly tested, and extreme values are tested, and model boundaries are identified. All the testing activities definitely need to be properly documented because the regulators in the internal risk review will review all those documents. If there are overlay adjustment or something, also need to be documented. So this slide basically is talking about a leading model development process as it performs a variable selection on a clear conceptual foundation and a clear, clean, accurate data. So we basically have 5 steps here. And the first step is to understand the business context and the initial planning. In the initial planning period, basically we identify the modeling needs. Is it a new developed model or is it redevelopment? And also in intended model use, define specific. You have to specify like in what's the dependent variable, independent variable, and targeted standards, articulate stated based on model use, and the reasoning for target standards clearly explained. And so the second step is the model data collection. And those with recorded of the data sample that is transferred to model developers. Those records of data, they need to be accurate and produce the data extractions from internal and external database. They base on a clearly defined data request specifying the required data definition, format, etc. By model development team, and record of the raw data kept for future performance, monitoring, and validation. So the third step is for model variable selection. And those perform the transformations on raw variables. For example, those legs and the percentage of changes in all those variables, and perform the single and multi-factor analysis to determine most statistical predictive variables. And use of management judgment to ensure that variables selected exhibit the balance between the statistical significance and the intuition. And the fourth step is the methodology documentation. And so it's all about documentation that is needed clean and clear. So the fifth step is validation. So today we're going to focus on all those 4 steps in this section. In the next slide, we'll talk about the business contents and understanding. So this is the first. The model development should begin and understand of the underlying business process and the line items and the planning around the model approach. So the first we can start with questions, and then the questions and topics about the business context. So we can ask like, why is this model development necessary? If it's necessary to develop a model, and then the example of information to be collected, such as the details that if you're interested in, you can look through this. So the model data selection is very important, and the data should be reviewed and understood prior to use in model development. So there are various sources of data exist. Internal data, external data. Internal data can be low-level data and aggregated level data. Also, external data can be purchased, from Moody's and the credit bureau. There are a few data sources, and we have to identify the consistency of the data. Balance sheet figures should reconcile with the trusted source. Stock and the flow variables should be consistent over time. And understanding relation to dependent variable. All the factors of approximate underlying drivers needs to understand how each factor relates to the item being modeled and assess intuition behind the direction of the relationship. And treatment of the special values in data. Basically, this is a clean clean the data set, and you can remove the outliers and the missing zeros, negative values, and you have to treat it in a certain way and document that. So the next slide, we're going to talk about the model data selection. When developing a model, and it's generally good practice to have 2 samples when possible. So as everybody knows, we have the training data sample and also the testing data. So for the training data set that required, it's about at least you have to have 15 to 30 observations needed per independent variable. So this is the minimum. The bigger the sample, the higher the confidence level of the statistical results obtained. Usually, banks' data pretty large, but it depends on the how long you have the history. Some new business that maybe you don't have long enough history of data to be able to build a model because you don't have the whole cycle of that economic cycle. So data required to perform testing validation of the model. A holdout sample is necessary to test out of sample model performance. And sometimes it's not possible to have a holdout sample because the number of dependent variable observations may not allow. So it's very good to divide the data into the development sample and also the testing sample, but sometimes just the sample size is small that you can't really do that. In that way, you have to use a subdivision sample to do the testing. So the next one, we're going to talk about the model variable selections, and it's the statistical approach. In it is used based on statistical significance. We basically analyze what kind of variable is relevant from the business point of view. So this example is just a step by step to how to select our variables. We have this. First, we can create our initial list. Let's say there are 350 variables, and then we'll apply variable transformations. Apply lag transformation to all variables, calculate percent change in absolute differencing for all variables, and then we perform a single factor linear regression and engage business. So at that point, if we perform single factor analysis between transform the independent variable and the dependent variable, and then we can basically, let's say, look at adjusted R-square and in other tests, and then we can eliminate some of those variables down to like 25. The next step is to perform multi-factor linear regression and consider the maximum number of independent variables desired in final model. So the simple it's the better choice, and we usually don't do very complex, a lot of variables, very complex models, because those can cause some like overfitting problem. So the last step is we perform statistical testing and final business confirmation. And we select the final variables based on variable intuition and review of target performance metrics. Evaluate all the variables for intuitionist of coefficients. Engage the subject matter and the business expertise to evaluate the appropriateness. So this is the model variable selection. It's just an illustration of typical iterative process between the model developers and the business experts to agree on final model variables. So there are a few steps that first we can see that the variable long list and then variable transformation and single factor analysis, multiple factor analysis, and our final model. So all those need to be documented. So you can look at into the details of how to select our variables and following those steps. And this is just a model variable selection example. In this example, basically, as a variable give you that there's some idea about this. If you see from the quarter legs, for example, the quarter legs from 0 to 4, and then t to I, then we see this not with this graph that not much detail. But if we can go to a quarter differences and you model on that, and then we see some detailed seasonality. And if we go a little further to formula develop into the percentage change over I quarters, and then we really see some detailed changes, and can show very clearly by showing percentage instead of absolute value. Okay, so this is the model variable selection section, and then the single factor analysis can be performed with a target performance metric defined priori to help with rank ordering of independent variables. And then some variables, that's maybe by statistical testing, it's not significant, but it still can be manually adjusted and selected to be in the model, because it's really make business sense. For this model variable selection and the multi-factor analysis aims to increase the model's predictive power by using a combination of available factors. So there's a number of model factors, and we can look at their coefficient of determination, and to compare that value, and to determine that how many factors we should use, and what kind of if we needed to use combine some, and we needed to eliminate some, and that's all a business decision. So too many factors can lead to model overfitting, and too few factors can lead to a larger influence than desired for a single model factor. We continue to look at the model variable selection, and an important aspect to consider when performing model factor analysis is to remove variables that are highly correlated. And that's a correlation table that is from this matrix, and you can see the F3 and the factor 3 and factor 4, they have a 70% correlation. So that is pretty high. You probably need to remove one of them. So model variable selection, there are several common approaches for selecting the final combination of variable in a model. We have those three approaches usually used in our industry, and the algorithmic variable selection, best subsets, and as per judgment. So each one of them have some pros and cons. That, for example, so you use as per judgment, you ensure that model will be intuitive based on management from a management perspective, but so from the but they may be not comprehensive, and does not signify a data-driven approach. So it may not really better fit for the model. The selection of the final multi-factor combinations can be based on a number of criteria that can be tailored depending on the model being built. So we look at we usually look at it from four perspectives. The first is the model predictive power, that is more important, and the results of other statistical tests to assess models, graphical analysis, intuitive assessment of relationship with dependent variables. Once the criteria has been defined, and custom dashboards can be created to present options to be discussed with the business, with the management. So we have those. Let's say this is an example of 4 models, and we can compare that for the variable. There are 3 variables we compare here. In model 1, you have a 3 months treasury rate. Model 2, you use market interest rate in loans. In model 3, you have industry production index. In model 4, you have real GDP growth. So we compare all those variables and test them with the R-square, and then we got from 88% to 96%. But at the end, we have this model 4 chosen as the proposed model, and because it's make more business sense. Also, the testing look pretty decent around all those tested models. The sample model methodology guidance, that's one is just for your reference. So it's important to follow all those guidance. It's a good business practice. Also, when the regulators come in and they really read those documents to understand the model. So the topic area should cover the general, their standard for general and purpose and use, data elements, data description, data assessment, data adjustments, and the conceptual soundness, and there are some details on that as well. Sample model methodology, sample model methodology documentation guidance 2. This is continuous part of guidance 1. So it's about outcome analysis, implementation, effectiveness challenge, and ongoing governance. So you can look at those guidance in detail if you're interested. And there are some common challenges encountered during the model development. And so model developer does not, for example, model developer does not allocate a sufficient time to fully understand the line of business and the items being modeled. So first of all, it's important for the modeler to fully understand the business, and usually the business people, they don't do the modeling. So that communication is very important. The raw data to be used for model development is not clean and complete, and this is very common because usually in the real world, the data has some kind of error in outliers and their missing data, all that. So you need to really clean that up in a way that is practical. Historical performance variable relationships are not indicative of future performance, and that can be a challenge as well. Over-reliance on the results of statistical testing without appropriate sense checking of results. So usually a modeler intended to just look at the math and statistics and really didn't care much about the sense of business, and that it will be very questionable by the regulators, and also it's not a very good practice. Statistical tests performed on the final proposed model may fail and need to adjust the model form or document the result and explain why no adjustment was made. So this part it's easy to understand. We have to adjust some models because of the scenario changes, and then maybe update some calculation methodology, or we sometimes have to redevelop the model. A lack of involvement of business experts to help develop model hypotheses and confirm final model results. And this is about communication between the modeler and business expertise. Insufficient time allocated for documentation, resulting in completeness materials. So usually documentation is a little bit time consuming, and that's not everybody like to do, but for business continuous practice, and we really need to pay more attention on the documentation. The next section, we're going to talk about model validation, and we're going to get to a few details, the model validation process and typical expectations, and also present an example that walks through each step in a typical model validation, and summarize the typical challenges and questions that intend to arise during the model validation. This model validation is a crucial part of the SR 11.7 regulatory guidance on model risk management. So that's a very important part. In the model validation, needs to identify model validation requirements, which are mostly related to ensuring that good practice for model development, implementation, and use were followed, and also discuss the incentive, competence, and the influence of the model validation group. So those are the two big parts of model validation. The validation process reviews and challenges all aspects of the model. This is started from the model's purposes through the performance. So the first is we look at the model purpose. So the model purpose, we have to clarify this business segments being modeled, and variables being modeled, data being used, and modeling context. So the model supporting materials, we gather all and review all the documentations and the informations and the data and the regulatory feedback. And for the third step, that conceptual logic, we perform detailed model logic evaluation, ensure the model form is appropriate for its intended use, and ensure variable selection and relationships are intuitive, understand the model assumptions and limitations. And the fourth step is development data. So we perform a detailed review of data quality, data transformations, and the treatment of data anomalies, such as outliers, missing data. Those are stuff that we need to all consider. The fifth step is analytical assessment of model performance. So basically, it's the back testing of the data of the model. And so from step 1 to step 4, and all the communications is very important between the model owners, developers, and the line of business people and stakeholders. The next slide, we are going to talk about this example of a high-level model assessment focused on the acceptability of CCAR models and the adequacy of documentation. So CCAR is comprehensive capital analysis and review. So you probably heard a lot about it in the banking industry. It's for from Fed or OCC. They check yearly on those big banks. Model acceptability, adequacy of documentation, and you can include those major points that all need to be included in the documents, because each one they will check all the details. So the next section, I'm give you an example of model validation. So this case study, we just use the debit card interchange fee model as an example to walk through all those validation steps. So first, we identify the model purpose. And model risk management has verified that the debit interchange fee income model is used to forecast components of PPNR as part of the annual CCAR exercise. So we see all the details of this forecast model, and you see this as time goes on, and you forecast all the monthly fees. And this model uses a linear regression to establish the relationship interchange data and the independent variable. So this is a historical chart on this one, and we look at the debit interchange growth data. And then the model, they cluster model documentations and development data and the implementation codes or spreadsheets to move forward with their validation. So we can ask those information from line of business, from the model owner, or from the model. If you are in the second line of defense, and they usually have all those information as well that we can ask for. And that's a model support materials that if you look at this chart, and you can see there this is data set for model collaboration, and here is the raw data set and the seasonality factors that applied to this chart. That this is example presentation review that they're including key theoretical concepts and key the model performance and general format, and then example of model development data sets. And that's an example of the output analysis. So usually you can use SAS, use R or MATLAB, all those tools to develop your model. Conceptual logic. So we had to analyze this this logic that review this structural form of the model along with the intuitive of each variable. So this is talking about modeling approach that in this relationship that we created, it's this independent variable and all this dependent variable beta as the different estimated coefficients. So this you can see this is residual series, and there are some variables that have this this increase in this relationship. Are they in the same direction or they're not in the same direction? This increase, decrease, and are they making sense in this? It's this step. So the next step, we're going to see the data flow. And the data flow, basically, sometimes you have external data, let's say from Moody's, and also you have internal data from corporate finance system and audited financials, and then you have to compare, combine those internal data together, and then finally, eventually, you merge those data files, internal and external, to do your forecasting, build your models. This one is dependent variable time series was reviewed to identify critical events along with treatment of those events in the model. And this is the seasonality is applied to this model, and you have this a few shifts. This is the outlier that it's tied back to incremental volume payment. It's a one-time shift, and this shift is acquisition. So that's jumped the chart, and this is basically it's a regulatory and Durbin amendment in 2010 that's made the shift on this model. The next slide will talk about the model performance. So we do some testing on the performance. That's standard statistical testing and visual inspection of results and the sensitivity testing. So those are three testing that we need to do for each model, and there are some advantages and pitfalls for each methodology. But basically, to do all of them, it's more helpful. The model performance is statistical testing, and this given the model was a linear regression. The testing protocol was designed to test its key assumptions. So we can identify all those key assumptions and do further testing. For example, this direction of coefficients intuitive, and then we use this filter that's the correct signs on every coefficient. All those details we can do t-testing and use the variance inflation factor to remove those collinear variables and look at the p-value. All those testing can be performed. This slide is visual inspection that helps to identify the problems, and it's especially helpful for backtesting and forecasting. And basically, you can see from this backtesting chart that the actuals and the predicted value there. This is over predictive, and this is under prediction. This two area. Even this is very good. R-square is very good. And for this forecasting, that for the stressed scenario, that you can see that the red, this is more conservative than the baseline. That is normal scenario. That is forecasted this way. So this is slides that we're talking about this the management risk, the risk management. They tested the sensitivity of the model based on the length of the data series used to collaborate the parameter, and also by stressing individual variables. So this is a sort of a stress test that we can stress the different variable. Then you can get this is the standard deviation that you can get different results. The communication is at the conclusion of the validation, and we provided the recommendations to the model developers. They're very important. They're basically graded by importance. There's three levels of importance. There's level 1, level 2, level 3 that you can read those details. And the common challenges that we encountered in our validation, and there are some common ones that are listed here. And for example, that if material change over the course of model validation, and the data is fixed while the validation is underway, so it's always something that is unmatched, that you have to really dig into further and ask for more information, and sometimes ask for a different, the data that the data they built the model, that you have to ask a certain period of data to be able to test what exactly the model performance is. Bob, I think at this point, I used a lot of time already. They're 12:50 right now. So I would like to take some questions, and also I have those a couple of appendix slides that is just some rule of thumb and some testing we do. You can look at it yourself if you're interested.
Yeah, thanks, Dora. That was great. You should write a book. Like, it was very,
there's a lot to go through.
It was. There was a lot of detail. It was very important. I think it was a very important presentation, because it's, there's lots of this, really cool, sexy stuff going on, data science and big data. But in the end, it's got to be applied and usable and work in the real world, in the business world, where there are lots of not just internal requirements, but as you mentioned, especially in banks, regulatory between Dodd-Frank and Sarbanes-Oxley and existing bank regulations. It's got to comply to all of that. So you can't just do some fun, sexy algorithms. It's got to work in the real world. I really think your presentation was an excellent guide of how to do that. It wasn't just theoretical or suggestions or opinions. Like, this is how you do this. And it's a very practical guide, and I really appreciate it. I think everybody else did too. And we do have a question. Let me get back to the question. It's one of our attendees, was actually a former manager of a bank modeling group. Says the approach is very deliberative, lots of human intervention. How are your efforts influenced by recent advances in highly automated modeling, machine learning technologies? Which kind of goes to what I was just talking about, how there's all this new cool stuff, but in the real world in banking, you have to do things in a very deliberate way. So do you do that? Do you explore or get exposed to, or what do you do when there's some new technique or technology comes along and you want to assess whether or not it's a useful tool to use?
Yeah, we those are new technology. Basically, we try to all the modelers, they expertise. Some are good with like a MATLAB, some good with SAS or R. So they just usually we're a group of when we develop an internal model, and a group of people work together and do the automation, different codes and all that. But usually we don't really chasing the cutting edge technology, because everything needs to be tested and to be validated before we apply to the model, to use some new model techniques. So we're usually pretty conservative, because the regulatory, they constantly checking on us and really have to make a business sense. So I don't know if that answered the question, or what do you really looking for?
No, I think that does. Right, I think it does, because what you're saying is, of course, these new technologies are great stuff, but it's such a complex environment with so many regulations. I won't say stifled, but it's going to be a really rigorous, disciplined process, and it takes a lot of time and effort to use the technology. So it's actually a pretty high barrier to doing something really leading edge. Is that an accurate
yeah,
statement?
and yes, and the modelers really they got a lot of challenges. You know, all the model validators will ask you questions, and all the regulator ask you questions. Internal audit, they really have to have a very you know, have a very good literature review to back up what their modeling methodology is and the technique they use.
Right, right, that makes sense. A question, why is variable selection linear?
It doesn't need to have to be linear. It can be non-linear. I mean, this is just an example, you know, of this model that uses linear. So, well, if you use SAS, let's say you can use, you know, this look at this slide. You can do like a step forward, backward, or stepwise to select your variables. But there are a lot of ways to select your variables, and even making statistical sense, but sometimes it has a conflict with business, sense of business. So let's say the macroeconomic variable that sometimes when you do your mathematical test, it's really not significant enough to be included in the model, but it required by the regulators. So you really have to be included in the model. So there, you know, it's all a balance. It's a balance of math and the real business.
Right, okay.
Sense.
One more question. Do you review assumptions in your predictive variables? For example, how GDP variability is expected to be?
Assumptions. I mean, the GDP used in the model, basically, your first assumption is, you know, this dependent variable, whatever you're forecasting on, you think it has some kind of relationship with the GDP. So it's the, you know, it can be really of GDP, or when you forecast, let's say you forecast the debit card fees, and how much GDP can influence the debit card fees, probably very small. But there are some assumptions you put in that say, you know, the macroeconomic situation really has an impact on the debit card fee. Then that's your assumption. But your assumption has to be backed up, you know, by your historical data testing, or by you know, you have a literature review that from some research paper that you can support yourself, and then you can collect all those information to support yourself.
Okay. Well, Dora, thank you very much. We're out of time. Again, I think this was an important presentation because it really gave some insight and some very practical advice and guidance on how to develop, implement, document, and comply with corporate and various regulatory, which are crucial. For everybody, this presentation was recorded. It will be available soon online at the Data Science Professionals website. So again, Dora provided a lot of detail, and if you want to review all the details or get into them, just go to the Data Science Professionals website and you'll see the recording online. So once again, Dora, thank you very much, and thank you everybody for attending. Until next time, goodbye.
Thank you.